On today's episode, a new private hypersonic rocket lowers test costs. Today's episode is brought to you by engineering.com, a globally trusted source for engineering content. Check out this and many other exclusive videos for the engineering professional found only on engineering.com TV today. Hypersonic flight is a hot area of aerospace research right now, especially for military applications. Flight speeds of Mach 5 or above greatly lower the vulnerability of airframes to defensive countermeasures such as surface-to-air missiles. Hypersonic flight in commercial aviation has been a dream for decades, but in both military and civilian applications, a great deal of research is still necessary to build practical, reliable systems. Hypersonic research is split generally into two regimes: propulsion and airframes. With current technology, propulsion is either by rocket or supersonic combustion ramjet, with the latter currently believed to be the closest to practical propulsion in reusable vehicles. Airframe structures in this high Mach environment are also difficult to design and build, with the necessity for extensive heat protection while maintaining an aerodynamically viable form. While normal re-entry vehicles such as the Space Shuttle and the X-37B provide some data, those platforms are relatively high drag and only manage flight in the hypersonic regime while decelerating to an unpowered landing. More data is needed, with military research organizations and NASA the primary drivers of hypersonic flight research. Now, the private sector is entering the field. Mojave, California-based Stratolaunch has announced the successful test of an air-launched hypersonic uncrewed test vehicle, the Talon A. Altitude and speed achieved by the TA-1 vehicle were not disclosed by the company, although maximum velocity was reported as approaching Mach 5. Mission objectives for this initial flight were to safely air-launch the vehicle, ignite the engine, climb under power and control, and splash down in the Pacific Ocean. The launch aircraft was the Stratolaunch Rock, 6-engine, twin-fuselage carrier which the company uses for space missions, but the firm has acquired a modified Boeing 747-400, formerly used by Virgin Orbit, as an alternative carrier. The company is preparing a second airframe, TA-2, which will be reusable. And reusability is the key. Current test platforms are disposable, requiring extensive support in the form of chase aircraft and telemetry systems to record data, and of course are costly. In the R&D phase, reusable platforms not only develop the complete technology, they allow the use of onboard data recording systems instead of telemetry, reducing the support infrastructure and also allowing engineers to examine the airframe post-flight. The successful test is significant not only for progress toward reusable hypersonic aircraft, but also for its potential to develop a private high-speed aircraft industry. As a private company, Stratolaunch can be contracted to gather data in hypersonic flight in support of customer-specific aircraft and missile programs. This proprietary data can form an important and valuable source of intellectual property for airframers and give them a competitive advantage in what will almost certainly be a crowded and lucrative hypersonic market space. Well, that's it for today's episode of This Week in Engineering, brought to you by engineering.com. For our deeper engineering series, visit engineering.com TV for exclusive shows like Manufacturing the Future, Designing the Future, and the Engineering Roundtable, not found on our YouTube channel. The links are in the description below. Thanks for watching.